Hi folks, Chris McClure here. We are going to continue this discussion of computing probability by combining two more simple uh, events in the form of the union of those two events and then calculating the probability of that union of two events. Hold on, let me pull up my pen here. Choose a color. Blue is my favorite color. Alright, so when you see the addition rule, that basically means we are going to calculate the probability of the union of two events. When you see the word or separating two events, that means that you're calculating the union. Now, when we see this or statement, it's the inclusive, which means that either the one event happened or the other event could happen. So, for example, suppose we want to calculate the probability of drawing either a heart or a face card when we draw a card from the deck of playing cards. So we're going to see how to calculate that. And the inclusive means that it could possibly be that the card that we draw is both a face card and a heart. Now, a compound event is an event which combines two or more simple events. So like I just told you, the event of drawing either a heart or a face card would be an example of a compound event in which you are combining two events by using some sort of operation like a union, or as you'll see in the next one, intersection, in the next lecture tomorrow. And anyway, the notation that we use is this one. Remember, the P stands for probability. A is one event, or is that union sort of activity, action that we're doing to combine A and B is the other event. Okay, that is the notation. So how we're going to calculate this probability is we're going to find the total number of ways that the event A could happen and that the event B could happen. And then if those two events could possibly happen at the same time, we will make sure that we only count once those outcomes that are in the intersection of those two events. So, for example, if we're wanting to calculate the probability of drawing either a heart or a face card, what we're going to do is we're going to count the number of ways that we can get a heart. And remember, there are 13 hearts in a deck of cards, and there are 12 face cards. But there are 3 hearts that are face cards, and if we don't subtract 3, then we will be double counting the number of heart face cards there. So 13 plus 12 minus 3 is 22. So there are 22 cards that are either hearts or face cards or both. And then we would divide by the 52 cards that are possible to draw in order to calculate the probability. So we have 22 over 52, or in other words, 11 over 26. So 11/26 would be that probability of drawing either a heart or a face card. That's an example of how to calculate the number of ways that you could get this outcome, as you see in the numerator, and then to calculate the probability by dividing by the total number of ways. You notice that I subtracted something. I subtracted the 3 when I said that there were 13 hearts and there were 12 face cards, but there were 3 hearts that were face cards / face cards that were hearts. Like I said, if you don't subtract off the number of elements in the intersection, then you would be double counting, and thus we would not have an accurate count of the number of ways that event could happen, or the other event could happen, or possibly both. We'd be double counting. So we subtract so that we don't double count. Okay. So however you need to do it in order to count the number of elements in the union. You could just simply, look at all the cards in the deck, and you can just simply count the number of cards that are either the heart or the face card, or both, without needing to fool around with adding and subtracting. As long as you are adding in such a way that every outcome is counted only once. And then remember to calculate the probability, you just divide by the total number of outcomes in the sample space, which for our example, there were 52 cards. So you divide by 52 because there were 52 possible outcomes when you draw a card from the deck. Now, if you want to look at a picture, here's a picture. With a Venn diagram, the universe is contained within the rectangle, and the red circle represents event A. Event A could be that maybe we drew a heart. Event B, maybe given by this yellow circle, could be the event that we drew a face card. And then the intersection that you see here, that would be the event that we drew a card that was both face card and a heart. So these the three cards that are the Jack of Hearts, Queen of Hearts, and the King of Hearts would be in this intersection right here. And this yellow piece outside the red circle, that would be all the face cards that are not hearts. And then this red circle outside the yellow, those would be the hearts that are not face cards. Now, if the events have nothing in common, and they couldn't possibly happen at the same time, then those two circles would not intersect. And if you want to calculate the probability of the one event or the other event for those two disjoint events, then all you would need to do is add the number of ways that event A could happen plus the number of ways that event B could happen. Again, only works if you have no intersection between the two sets. So, for example, if you want to calculate the probability of drawing a heart or a spade, no, not spade, yeah, spades. Well, there are 13 hearts and 13 spades. There's a 13 over 52 chance of drawing a heart and a 13 over 52 chance of drawing a spade. So that would be 26 over 52, or 1/2. So there is a 1/2 chance of drawing a card that is either a heart or a spade. Remember, you don't need to subtract anything in this case because there's no intersection. Versus over here, when we were looking at the probability of drawing a heart or a face card, there was an intersection, so we did have to do some adjustment so that we're only counting each card once. Just as a reminder that when you have an event and the complement of an event, those are two sets that are disjoint. You cannot possibly have a card that is both a spade and a non-spade. And sometimes, like we saw in the previous lecture, it's easier to calculate the probability of the complement of an event compared to the straightforward calculation of the probability of an event. And remember that the probability of an event plus the probability of the complement of an event is equal to 1. Which should make sense anyway, because an event and its complement make up the entire sample space. Look, when you draw a card, you're either going to draw a spade or you're going to not draw a spade. You're going to draw a card that's something other than a spade. One or the other, you're going to draw something. So that means the probability of drawing a spade plus the probability of not drawing a spade is going to be equal to 1. And if you know the probability of the complement, then you can subtract from 1 to get the probability of the event, or vice versa. If you know the probability of the event A, then you can calculate the probability of the complement to be 1 minus the probability of A. So you know that the probability of drawing a spade is 13 over 52, or 1/4. 1 minus 1/4 is 3/4. So that means that the probability of drawing a card that's not a spade is equal to 3/4. Okay? For example, remember that the event A and its complement make up the entire sample space. That's why the probability of A plus the probability of A complement is equal to 1. So that's it for today. Short and sweet discussion regarding calculating the probability of one event or some other event. All you need to do, let me just remind you, all you need to do is to calculate the probability of the one event plus the probability of the other event minus the probability of the intersection, and then divide by the 52, or however number of ways that you could possibly have an outcome. And you would end up with this probability of the one plus probability of the other minus probability of the intersection. Okay? So you could either, and let me just clarify this, by the way. When I did 13 plus 12 minus 3, let me pull up my pen here. You know, I really should be divided by 52 in order to get these individual probabilities. Otherwise, I can just do 13 plus 12 minus 3, all divided by 52. So you can calculate the individual probabilities. Probability of getting a heart plus the probability of getting a face card minus the probability of getting a face card heart. Or I can count the number of ways of getting either a face card or a heart and then divide by 52. Either way will work in computing the probability of the union of two events. The word union is the same thing as saying the word or when you are pronouncing the name of the union. Okay? So that's it for today, and we'll see you next time. Oh, by the way, sorry about that. Final exam, I sent an email out earlier. It turns out that our class is on the 8-week schedule, so we're going to take our exam closer to about the 15th of the month. So now I sent an email out that the window that I'm hoping to get everyone to take their final exam is between the 10th and the 14th. And I'll also take a look at when later this month I'll start sending out the midterm exams. Okay, so we'll talk about that a little bit later as to when the midterm exam is going to be. All right, next time.